Hello guys, welcome back. So in the last video I talked about a simple example, right? 3 or 4 simple examples in which the fundamental properties or the equations of limits come into play. So in this example or in this video I will be explaining about 2 examples in which the next theory of limits come into play. So in the last example, as I mentioned a little while ago, I explained about the basic concepts of the basic equations. So in this video I'll be focusing on this theorem when limit of this quantity equal to n times a n minus 1, right? So this is the theorem I'll be using in this video. I'll be explaining two practical examples in which this theory comes into play. Alright, so the first example I'll be taking, is this one. So if you are given something like this, a simple thing, x cubed minus a divided by x minus 2. Right? If you're given a simple sum like this, how we can put this? So we have to understand, first of all, as I mentioned in the last video, in the concepts of the video I explained about this concept, about this theorem. As I mentioned, that what you have to understand here is that here is x minus a, here is x minus a. So if here is x and here is a, what actually happens is that on the left side of this arrow it should be x, and the right side of the arrow should be the minus component, a, and the power of these two powers should be equal, and the value of x should be directly here, and a should be directly here. So what actually happens is that you are raising the quantity of x to a power of n and subtracting the raised quantity of a to a power of n divided by the unraised quantity x, right? So this is the raised quantity up to a power of n. So this is the unraised normal quantity, and this is the raised quantity, and this is the unraised, right, or the normal quantity. So if we have something like this, the value of that is equal to the power of this, right? These two powers are equal. Power of this times the constant here times n minus 1, or we are subtracting 1 from one of these two powers, right? So in order to put that, what actually happens is that we have to have, if here is x, we have to have x here, and here you should have a minus value, and this should be here as minus as well. So if here is n, here should be a, right? If here is a, here should be a. And in this example, what actually happens is that now here is x, right? So we have to have x here, so it has been given, so it's alright. So here's the minus component, here's the minus component, that's also okay. And if here is 2, and the right side of the arrow should be also 2, so that's also correct. So what actually happens is that when x is raised to power 3, 2 should be raised also to a power of 3, because these two powers should be equal in order to apply this equation or this theorem. So what actually happens is that we can write 8 as 2 to the power 3, right? So that's the first step of solving this equation. So this is limit when x goes to 2, x cubed minus 2 to the power 3, right? X to the power 3 minus 2 to the power 3, because otherwise we can't apply this equation, divided by x minus 2. So here is x, we have x here is minus value, and here we have a minus value. Here is 2, and we have 2 here, and if this is x, this should be some power of x, so we have to the power of 3, and this should be, if this is 2, this should be also to the same power. So we have the general, right? We have the general equation here, general format that is being expected at the left part of this theorem, right here. So we can directly substitute the values of n and a to find the solution. So this will be, so n is a power of these two, either the value of to the power of x or to the power of 2. So both instances they should be equal, and that is 3. and the constant here is 2. So n is 2 and a is 3. So the value of n times, so we have to substitute the values of n and a here. So n times a to the power n times a to the power n minus 1 is equal to n is equal to 3 times a is equal to 2 to the power 3 minus 1. So that will be 3 times 2 to the power 3 minus 1 is 2 to the power 2, which is 4. So 3 times 4 is equal to 12. Right? 3 times 4 is equal to 12. So that's a simple example in which the theorem comes into play. Now what actually happens, now there may be complex examples in which you were given a square root. Square root, what I actually mean is a root of something, not to the power, only to the power half, maybe to the power of 1/3, or maybe to the power of 1/4, or 1/10, or 1/millionth, if you're given something like that. How we can solve that? So let's take a simple example. So that's the second example that I'll be focusing on this video. So if you are given something like this, right, limit of x to the power 1/4, right, limit x to the power 1/4 plus 3 divided by x plus 81. You have to find that when x goes to minus 81, right? So the theorem that I'll be using, the principle that I'll be using is this one. When x goes to a, the limit of x to the power n minus a to the power n divided by x minus a is equal to n times a to the power n minus 1. Alright, so what actually happens is that we have to make this into that order. Alright, so first of all we have to arrange if it is not arranged. So let's see whether the equation on the left side, the arranged part of the left side of this theorem is as it is. Alright, so here is some power of x and here is some power, right? Some power of something, right? So the value of x is here, right? X is here and x is here. 81 is here and we can write 3 as some part of 81, right? Some power of 81. So that's okay. But what actually happens is that we have a positive value here, but in the equation we should have two negative values. And here is minus 81. So in the equation we had a positive value here and x is here. So what actually differs this from the original equation is that we have a negative value here and we have two positives, or we have added these two, right? So what we can actually do when x goes to minus 81, what actually happens is that we can also write this one as limit when x goes to 81, right? From one of the first theories that we learned under limits, you can say when this x goes to minus 81, this term, when x goes to, if this term goes to minus 81, right, this is equal to when x goes to 81 of this one. So x to the power 1/4 minus 3 divided by x minus 81, right? X minus 81, right? So that's simple. So what actually happens is that now we have this theorem. Now when x goes to some positive value, so this x is here and this positive 81 is here. So this x is raised to some power, that's 1/4, and 81 can be raised, 3 can be written as some power of 81. So 81 has been raised or decreased to some power. And here is minus and here is minus. So those are the conditions that we need in order to apply the equation. Alright, so what we have to find, what we have to do again here is that if x is decreased to a power of 1/4, we can write 81 as 3 to the power 4, and conversely 3 can be written as 81 to the power of 1/4, right? 81 to the power of 1/4. So what actually happens is that in order to put the equation, in order to apply the equation, apply the theorem, we have to write 3 as 81 to the power 1/4. So let's see what happens. So limit of x of 81 minus 81 fourth divided by x minus 81, right? X minus 81. So this is the value you will get when you simplify this. So x is raised to value of 1/4, 81 is raised to a value of 1/4. So these two powers are equal now. We have two minus signs. This value is the same value here. This value is the same value here. And this value is in the left side of this equation. This value is in this right side of this equation of the actually the arrow, right? Not the equation, arrow. So we can directly put, we know the value of n and we know the value of a. So we can directly substitute the values for the left side of the theorem. So that will be, so the right side of the theorem will be n times a n minus 1. So n is equal to this power 1/4, a is equal to 81. So n is equal to 1/4, a is equal to 81 to the power 1/4 minus 1. Right? 1/4 minus 1. So that will be 1/4 times 81 to the power minus 3/4. Right? 81 to the power minus 3/4. So that will be 1/4 times 3 to the power 4 to the power minus 3/4. Right? Minus 3/4. So what actually happens is this is 1/4 times 3 to the power minus 3. That will be 1/108. Right? 1/108. So that's just a simple example in which the equation, the theorem that we have been using, the second theorem of limits, this theorem is being used. So a practical example. So in the next video I'll be talking about another theory, right? Another theory. Next video I'll be talking about another theory of limits. So thanks for watching this video and see you then.